Today's a massive day in the world of web development. The title is not clickbait at all. It's so real that I woke up at 7 a.m. today just to make this happen. And if you know my sleep schedule, you know how absurd that is. Today, Microsoft announced something I never thought I would see: a native port of the TypeScript type checker. And to be clear, this isn't just the compiler. It's not just the part that converts your TypeScript to JS. We've seen that done in other languages before. This is the type checker, the thing that makes sure each type in your code base is accurate and correct. That has historically been nearly impossible to do in other languages. I went as far as to say it is impossible. I've been proven wrong. This is an incredible project. I'm lucky enough that the TypeScript team reached out to me early to take a look, and I am so excited to share all the things I've learned about this project. TypeScript Go is a massive change for the entire TypeScript ecosystem, and you definitely want to know everything you can about this. If you're curious about how much faster it is, it's around 10x faster, and if you're curious why they didn't use Rust, you're going to have to wait till after the sponsor. I think it's fair to say that React made it way easier to build apps. Well, half of them at least, the front end half. It doesn't help a whole lot with the API side. We've tried to solve it with stuff like, GraphQL, but let's be real, that hasn't helped a whole lot. That level of abstraction does not make your code better. It actually makes it a lot worse. We've also seen people try to make these fancy UIs where you can check boxes to generate an API. That's even worse. Let's take ourselves seriously for a second. If we want to make things easier, we need to really rethink what the backend looks like. And that's what today's sponsor, Convex, is here to do. They call themselves the missing half of your React app, and honestly, I agree. It's the first backend solution I felt really understands React and makes it easier to make reactive applications. Even something like a to-do list can actually be a lot easier. I know it seems like the simplest thing ever. Go add the backend to it and make sure it handles when something's checked in one place and not in another with proper updates. It's not as easy as it might seem. Unless you're using Convex, then it's literally just one line of code here to set this to true or false. And this set complete function that you define in your Convex folder is actual code in your code base that you can import on the client that does what you expect it to do, fully type safe, back to front, with live sync, by the way. Do you know how hard it is to get live syncing for stuff like this working? Not fun. Don't deal with it if you don't have to. Literally just count to-dos is use query api.todos.list. Looks just like tRPC, but the whole backend is already built. Normally, you'd have to worry about lock-in, but not with Convex. It's fully open source, and they just put out a bunch of guides to self-host it too. If you're tired of figuring out all the pieces of your backend, from auth to file hosting to databases to server functions to WebSockets to live updates, Convex is the easiest, cheapest, fastest way to get going and not have to worry about that. If you want to build a great UI for your users, stop worrying about all that stuff. Try out Convex, and you'll be moving faster than ever. Check them out today at soidev.link/convex. I love that Anders is the one who wrote this. He also did a cute YouTube video. There will be little clips and moments from this shared throughout, but when you're done watching this, I'd highly recommend watching Anders' video. It's really good. The core value proposition of TypeScript is an excellent developer experience. As your code base grows, so does the value of TS itself. But in many cases, TypeScript has not been able to scale up to the very largest code bases. I read an early copy of this blog post, and the formatting is so much better. I gave a bit of feedback, and it's cool to see it all integrated. The thing we actually care about here, though, is this guy. Testing on the VS Code code base, they saw a performance change from 77 seconds for a compilation down to 7.5 seconds. On a code base like Playwright, it went from 11 seconds down to 1.1 second. I also love the tRPC shout out here that the tRPC client is 9.1x faster. If you've used big code bases with tRPC, you know how much a game changer this is going to be. I'm so excited. They do call out that this isn't feature complete, but that doesn't mean you can't run it on real code right now. They haven't distributed a binary, but I already set up Go so I could compile it locally and show you just how powerful it is. This doesn't just affect your build and type check times either. This helps your editor performance a ton. Your IDE actually uses TSC when you're doing all the IntelliSense stuff. So when you hover over something to see what type it is, that is using TSC under the hood in order to know what your types are. It's also the reason you can edit your code without having to save and still see the types that have changed and what might be right or wrong in your code. That is not an easy thing to do, much less run performantly. They've already gotten this working in VS Code. And there's one other really nice detail here where they are moving to a traditional LSP. LSP is Language Server Protocol. It's the concept that VS Code built in order to make it easier to integrate other programming languages with a protocol to track what those languages are giving for feedback to the editor. TypeScript was invented before the LSP was, so TypeScript's kind of built into VS Code. Now they're going to treat TypeScript more traditionally, the way every other language is. No more special treatment. The LSP is the standard way to do things, and it also means all the benefits to this rework are going to be seen in other editors as well. So you NeoVim people, you should be pretty hyped. The first test I tried to run was the TypeScript code base. calling TSC with the diagnostics call so we can see what it thinks the reported time is, and we can run it ourselves as well right after. As we see here, it ran in about 60 seconds of like user-facing time, 40 seconds proper total wall clock time. If we compare this to the new stuff, though, we get an error. But despite getting the error, we actually blast through this in 1.56 seconds of user time. So that was instant for me. This felt like 60 seconds. This felt like 2. It's pretty nuts. Sadly, I have not been able to get playwright compiling without a bunch of type errors. When we run it through the official TSC, it takes about 4 seconds. The new version takes 0.5 seconds. That's insane. This one has a few more type errors, but not a lot more when you consider that it's a raw port. It found 213 instead of 190. That's nuts. It's actually really close. Is it sad that I can't repro the exact test they showed there? Yeah, but the fact that I can run it at all is nuts in and of itself. And these numbers have panned out from everything I've seen so far. It does pretty consistently hit a 10x performance win. In order to get performance differences like this, there must be some crazy stuff going on the rewrite, right? Like they must have entirely rewritten and rethought all the logic. No. It's actually a big part of why they chose Go. If we look at the checker code here, and by the way, checker is the main TypeScript file that defines everything for the TypeScript checker, which obviously is written in TypeScript. This is a 50,000 plus line of code file. I'm just going to pick this particular function because I think it's a good example. Get type of symbol. It's a very commonly called function that's used to determine with a given symbol in the AST, what should that be? This function looks like this, relatively simple and readable. Let's compare it to the same function in Go. You might notice something here. These are basically identical. The TypeScript team went out of their way to find the language that would allow them the best performance on native platforms with concurrency and parallelism without having to meaningfully change the way the language is written. Most of the code for this initial version was processed and transformed over via a script. They wrote a script to port the TypeScript code over to Go. Obviously, it was far from perfect. It got the syntax right, so it would compile, but it didn't get the behaviors quite right. So they've had to massage it a ton since. They've done it, though. But as a result here, it's relatively easy for a dev who's been working on the TypeScript code base for a while to come over and make these changes. Not to say that any random one of us, even I, could do this. Like, no. The work on the TypeScript compiler in the TypeScript version is insanely difficult. And the things they did to make that performant, their knowledge of the JavaScript VM and all the hacks they made to make that work are unbelievable. But they did it. And the performance they got out of the TypeScript version in and of itself was pretty nuts. But a raw port over with no changes made to optimize performance has already seen a massive win. And I have to point this out. If you go to that checker TS file on GitHub, it won't render it because the file's too big. It's 3 megabytes of just one TypeScript file. That's why I had it in my editor. It's time to talk about the question everyone is asking everywhere. Why not Rust? I'm going to quote myself first and foremost here. Go is probably the right language for most JavaScript build and dev tooling. I said this back in February of last year, over a year ago. Aged pretty well if I say so myself. Why though? I'll be honest, I'm tempted to make this its own whole video, so I'm going to give you the overview here, and if you guys want more info on this, we'll break it down more in depth later. First main point is, obviously, simpler syntax that's more like JS. We saw that with the example I just gave. Another, probably much more important piece is more flexible structures and type system. One of the reasons that TypeScript was really hard to write in a language that wasn't JS-based is because JS itself is so flexible. You can just kind of add properties to anything at any point. If you have an object, you can just add another key and it will handle it. Because of that, the type checking stuff has to have similar flexibility. So if your tooling isn't prepared for that, good luck, have fun. But there's another really big piece. Concurrency, parallelism. JavaScript is a single-threaded language. People like to point at that as the reason TypeScript and JavaScript are so slow. They actually tend to be fast for a lot of application code, though. The magic of V8, which is the main JavaScript runtime, is that that thread can perform incredibly well due to the event loop. When something is blocked on I/O or other background processes, be it you're waiting for a database call or you're waiting for some file to load, you can do other things in the process. So the user can type and get a response immediately while you're waiting for other things in the background. But it cannot do multiple things at once. This is fine for stuff like web servers because a web server is mostly waiting for random things to happen and it can process requests and responses very quick. That's why Node's actually a pretty good backend language. What it is not good at is workloads that benefit greatly from multi-threading, like, compiling. And don't take my word for it.
This is Anders Heilsberg, lead architect of the TypeScript project. The JavaScript runtime platform is really optimized for UI and browser usage, and not so much for compute-intensive workloads like compilers and system-level tools. And we've likely reached the limit of what we can squeeze out of JavaScript.
As much as I like to crap on Go, and believe me, I am not a fan of Golang. I hated writing it so much that I accidentally became a front-end dev so I could avoid it at Twitch. It is really good for this because it has parallelism built in as like a language primitive. Any function can defer at any point. It's very easy to split things up and share memory across them. You can do web workers in JavaScript, but those workers can't share memory. They have to pass things over an event bus as JSON. And the serializing and deserializing of that JSON makes the performance characteristics worse than if they just did it single-threaded. So the biggest win, apparently greater than 50% of the perf win, comes from the ability to run this parallel. Type checking in parallel isn't as trivial as it sounds, by the way, because any one file in your system that you're type checking could be referenced in lots of other places. So the parallelism's actually doing a ton of redundant work where any set of threads might be checking the same files, even if they started somewhere different. This ends up working out okay, though, because they can dedupe the errors once they collect them all at the end and only show you the ones that are unique. So if it checks the same file 15 times on different threads, you'll still only get one error. And since it's so much faster, it ends up being better regardless. The one cost there is memory usage, and memory is higher than if they didn't recheck things, but it's still about 50% less memory usage than it was in the JS version, and that's without any work put into optimizing memory, by the way. Kinda nuts. There is one last piece here I want to very briefly touch on. If I do a video on this, it's basically going to be dedicated to this point. Garbage collection. Garbage collection is a strategy for managing memory in applications. Generally speaking, GC is a process that goes through and sees what stuff isn't being used anymore and cleans it up from memory to free up that memory. In languages like Rust, you have to manage your memory yourself, but Rust also has the borrow checker, which makes it a lot easier to know what is or isn't in use, so it's trivial to keep things free. However, you have to be constantly checking what is accessing what memory, which makes writing it significantly harder. If you're optimizing for the perfect memory footprint and making sure you never have to take a break from processing in order to clear out your memory, that's a great win. But if you're building something like a compiler where you don't care about the latency at any given moment, having to take a break to do garbage collection is actually pretty nice and allows you to write code in a much simpler, greedier fashion. Garbage collection is good for a lot of things. In particular, I think this use case is very good for it. It might hurt on something like a web server because if a user is making a request while you're doing GC, that request is going to take much longer to resolve than it would otherwise. You'll get crazy latency spikes. But if the process is going to take multiple seconds anyways, and it does hit a GC, who cares? Yeah, Rust is a phenomenal pick for this. Quick thoughts from the lead of the TypeScript team. Thank you, Ryan, for dropping this as quickly as you did when this all came out. We definitely knew when we chose Go that there would be people questioning why we didn't choose Rust or others. Funny enough, if you didn't know this, Anders Heilsberg, the creator of TypeScript, also created C#, so they explored that as well. But their conclusion is that Go was the right call for a combination of its portability, because it will work on multiple systems. Apparently, Go's Windows support hasn't historically been great, but I am sure Microsoft will fix that. In all of the demos, they used Windows, so makes sense. It's even possible that the issues I was having are because I'm on Mac, not Windows. Also, go to hit subscribe on the MS Dev channel, because if they're going to post stuff like this, I want to keep an eye on it. They explored lots of options to try and make this work in Rust, but all of them either had unacceptable trade-offs between perf and ergonomics, or they developed into some crazy write-your-own-garbage collection strategy. Some of those came close, but they resulted in lots of unsafe code, and it didn't seem like something like Rust had the primitives to do the ergonomic, flexible thing they needed to handle all this JS code. Pretty unsurprising when phrased this way. Most languages don't prioritize making it easy to port from JS or TypeScript. In the end, we have two options. Do a complete from-scratch rewrite in Rust, which could take years and yield an incompatible version of TypeScript that no one could actually use, or we could just do a port in Go and have something usable in a year. Hopefully you understand here. I love this joke too. It's not even super clear what the upside of doing this in Rust would be, apart from not having to deal with so many "why didn't you choose Rust" questions. And not to shit on the Rust guys as much as believe me, I love to. I just need you guys to see how many of these we got. Leave it to Microsoft to not pick Rust. Why do you think they didn't choose Rust? In before all the people say, why not Rust? Why didn't they choose Rust? Rewrite the Rust compiler and go. Good joke. Rust enters the chat room. Why not Rust though? Go is cool and all, but then it would be 100 times fast. No, not at all. Even just getting the parallelism working here in Rust would be miserable. Rust's concurrency layer is something left for you to deal with yourself. There's a reason why Tokyo is as popular as it is. I've gone too far down this tangent. I didn't want the whole video to be why not Rust. Dedicated video, probably coming soon. Just wanted to express some frustration as well as support for the Go team. Even though I'm not the biggest fan of Go, it was the right call for this project. I am hyped that they picked it. I am hyped that it's going as far as it is, as quickly as it is. And I am beyond hyped to share the planned release date. They expect to have a full preview of a native implementation of TSC ready for you to install and run in command line by mid-2025 this year. And they also expect to have a full project build and language service working by the end of the year. That means ready for VS Code by end of year. You can do it right now, though. Even my dumbass was able to figure this out, so it can't be too hard. They have instructions in the repo for how to set everything up. You can even run it as an LSP already. I didn't have time to set this up just yet before recording, so definitely check this out if you're curious. It looks really, really cool. I love that they're using the debug options in VS Code to trigger it. Awesome stuff here. The biggest catch, though, and this is the one that's made it a lot harder for me to test, JSX is not ready yet. JSX is the syntax used for those little React component-looking HTML things in our React code. That's not supported just yet. It's still supporting a lot of stuff, but it means I can't run this on my code bases to see the performance win yet, because almost all of my code bases have JSX of some form in them. They also confirmed their plan for the roadmap, which is that TypeScript 6.0 will introduce some deprecations and breaking changes in order to align the TypeScript in JS version with the TypeScript in Go version. And then TypeScript v7 will be the official version where everything moves over to Go by default. Awesome plan to get this rolled out. They want to make sure everybody with giant TypeScript code bases is able to benefit from these wins. And it makes a lot of sense. The goal of TypeScript from day one was to make it so that JavaScript could scale to companies and code bases the size of places like Microsoft. When Microsoft tried to write JavaScript code, they ran into the absolute shit show that was trying to keep it working when lots of devs are contributing to lots of files in lots of places. TypeScript was written by unders to solve this problem. And despite solving it really well, it introduced a new problem, which is when we have these giant code bases, the performance of the type checker goes to shit. Now they have solved it. And once again, TypeScript is the solution for gigantic applications that work on every platform, written by big companies, while providing incredible developer experience. The TypeScript team has historically focused on developer experience first and foremost, and I think this is the right path for them to really improve that DX. One last thought, because it's a thing I've been thinking about a lot, and I do think it fits here. The future of dev tools. I have a video coming out soon, it's already recorded, called React is the Last Framework. The hypothesis here is that we have all these AI tools that have been trained on the existing data. There is so much data for things like React and TypeScript that introducing a new framework or language is a hard thing to sell because your AI will be worse at writing those things because there just aren't as many examples. And this doesn't just affect other frameworks and other languages trying to catch on. It affects React and TypeScript too. The big thing that I've been seeing is that React and TypeScript can't really add big new APIs as easily because the likelihood that the education materials that exist, the existing code bases that are referenced in the AI that we're using to write all this stuff will even know about those features is near zero, which is why we saw the React compiler, which was an attempt to take your existing React syntax and spit out faster code. It's also why we now have the TypeScript Go compiler, because it doesn't change our syntax at all, but still gives us a massive win. And I think the future of our dev tools is going to be stuff that looks more and more like this. Stuff like UV in the Python world, which makes it way faster to scaffold and set up your development environment in Python. Also things like Mojo, which is in the Python world a way to write Python-looking code that compiles to much faster C. I think these tools are examples of where we're going with software, where instead of changing the syntax and ergonomics of how we work on and write software, we're going to get tools that improve the existing way we do things. And it's so cool to see Microsoft embracing this as hard as they have. There are lots of other benefits in the AI world here. In particular, when you have type checking performance that's this much better, it becomes significantly easier for things like an AI bot to use a tool to check your types as it is working on writing code. If it had to wait 30 plus seconds before it could continue, not great. Now, if it has to wait under 3 seconds, suddenly these tools become more and more useful for getting an AI to make changes to a giant code base and check along the way if those changes are right or not. So cool. There are so many ways a project like this could have gone wrong, and it's incredible to see the TypeScript team avoid all of them in the process. I'm super hyped about this project. I think it sets an incredible precedent for what we should expect from DevTools in the future. Huge shout out to Anders, huge shout out to Daniel Rosenwasser and everyone on the TypeScript team, both for pulling me in early, taking my feedback, and making all of this happen. I couldn't be more hyped to be a TypeScript developer, and you guys keep making it worth it. Let me know what you guys think, and until next time, keep type checking.